Swayam Prabha. Digital India. Educated India.
Now, for the center of the cross section is we have found. Now, the center of the cross section is this, that is the CG, and the ensure axis would be, this will be y and z axis, that will be your y and z axis, okay, about the CG. Now, I am interested in finding IZZ moment of inertia. IZZ about the center of the cross section is what I have to find. Here what we make use of is what is called as the parallel axis theorem to find the moment of inertia. Okay. Here we are going to use parallel axis theorem to find IZZ about the central axis. Okay. What does the parallel axis theorem state? Basically, if y is measured about the centroid of the cross section, okay, then if I have y which is y centroid plus some distance y naught, okay, integral y square dA, where A is the area of the cross section, is given by y centroid plus y naught square dA, right. Now, y centroid plus y naught whole square dA, this will be nothing but integral y centroid squared dA plus y naught is a constant. So, it is y naught square integral dA area of the cross section plus 2 times y naught integral y centroid dA area of the cross section. Okay. So, this is going to be nothing but IZZ about the centroid plus y naught square into area of cross section, y centroid integrated over dA, your axis is about the centroid axis. So, this term will evaluate to be 0. So, you get this term will evaluate to be 0. So, IZZ about some axis is IZZ about central axis plus A times y naught square. Okay. Okay. So, we will use this theorem now to find IZZ of this I section. Okay. Now, I know that the CG of the bottom flange is at this point. Okay. So, and I know that IZZ about IZZ of the centroid of the bottom flange is 1 by 12 BF into TF cube. Okay. We saw that for a rectangular section, this comes from the rectangular section, this is Z and this is Y of the centroid, and if this is H and this width is B, IZZ is BH cube by 12. We saw this in the last lecture. From here I extrapolate for the bottom flange, wherein the thickness now is TF and the width is BF. Okay. So, from there I get IZZ of the bottom flange to be that, and now IZZ about the CG of the cross section for the bottom flanges, then IZZ about the CG of the cross section for the bottom flanges BHQ by 12 BTF Q by 12, that is about